Okay, section 3.1, functions. A lot of what you're going to see in today's lesson is stuff that you've already seen in previous lessons. Should be pretty easy for you. It says a function is a rule that relates a set of inputs to a set of outputs. Each input, which is your independent variables, your x's, will have a single output. If it is a function, each x will be paired with a single y. And we've already discussed that once this year. The domain is all of your inputs, all your x's, and the y's is all your outputs. Example 1 says f of x equals the square root of x squared plus 5, and it says find f of 3, f of negative 4, and f of 0. Here we go. To find f of 3, again, all that means is simply plug in 3 for your x and tell what it's equal to. F of 3 is going to equal to the square root of, instead of x squared, you have 3 squared plus 5, which would be the square root of 9 plus 5, which is 14. You can write that as a square root of 14, or you can write it as, you can type it into your calculator and get a decimal approximation. That's going to be somewhere 3.7, 3.8, something like that. The second one says find f of negative 4. That would be the square root of negative 4 squared. Be careful with your calculator, because if you type it in wrong, it's going to give you negative 16. It's not. Negative 4 squared is 16 plus 5. That would be the square root of 21, which would be, where? About 4.3, 4.4, somewhere around in that neighborhood. Good. And the last one, f of 0. Plug in 0 for x, you get the square root of 5, between 2 and 3. We say that to say this, because next up it gets a little bit more difficult. I'm just erasing where I worked it out. Example 2 says f of x equals x squared plus 2x plus 3, and I do want to slow down while y'all catch up with me on that. Okay, f of x equals x squared plus 2x plus 3. We're asking the next problem to find f of x plus h. Then we're going to find f of x plus h minus f of x, and then we're going to find f of x plus h minus f of x divided by h. This is leading up to the definition of a derivative, which we might talk about this year, might not, I don't know. All depends on how much time we have. The first one, f of x plus h. My calculus group pre-calculus group had a lot of trouble with these last year, but they're not hard if you'll pay close attention. How do you find f of 3? You plug 3 in for x, right? How do you find f of 4? You plug 4 in for x. You will plug in x plus h for x. Everywhere you have an x, plug in x plus h. Makes sense. So instead of x squared, you have x plus h squared. Instead of plus 2x, you have plus 2 times x plus h plus 3. Now let's take and clean that up. Yeah, we're going to full it out, we're going to distribute it out, we're going to combine like terms just to make it look better. X plus h squared, I'll come over to the side, that's x plus h times x plus h. You should be getting a whole lot easier, or a whole lot better at fulling. This shouldn't take, hopefully you get to the point where you don't have to set and show every step. X times x, x squared. X times h is xh. Plus xh, which will be plus 2, it doesn't, plus 2xh, plus h squared. Any question on how to fold that? Now we got to do 2 times x plus h would be 2x plus 2h, and then plus 3 tacked on the end. Can we combine any of that? No, we cannot. No, we cannot. So therefore, that would be f of x plus h. That's fine. That's fine. You can write it in any order you want to. But here's the thing. Next problem, and that's the next problem is really the reason I folded out. Next problem says find f of x plus h minus f of x. Here's where people get lost. Now, I've yet to figure out why. We're looking for f of x plus h minus f of x. Yes. Then we're going f of x plus h. We just found that. x squared plus 2xh plus h squared plus 2x plus 2h plus 3 minus f of x is what we started with. Y'all remember that? There's f of x squared plus 2x plus 3. Let me write that down. F of x is x squared plus 2x plus 3. And we're doing this, f of x plus h, minus that. That's it. So that would be x squared plus 2xh plus h squared plus 2x plus 2h plus 3 minus. Make sure, since we're doing minus all of f of x, put it in parentheses. Minus x squared plus 2x plus 3. This should clean up a little bit. Any question on how I got that? This is f of x plus h minus this is f of x. Yeah, a lot of stuff will cross over. Yeah, a lot of stuff crosses out. So I now have x squared plus 2xh plus h squared plus 2x plus 2h plus 3 minus x squared minus 2x minus 3. What all cancels out? X squareds, 2x, and 3. And leaves you with So here we go. So f of x plus h minus f of x. We've cleaned up all that we could. There it is. And the third step, or C part, says, if I go back to it, it says find f of x plus h minus f of x. Do you see the top is what we just did, divided by h. So we've just got to take what we just did and divide it by h. Watch how I do it. 2xh, this is C part, 2xh plus h squared plus 2h divided by h. You simply, here's the thing though, you have 3 terms on top. You've got to divide all 3 of those terms by h. You can't just do one of them. That's it. 2xh divided by h would be 2x. H squared over h is h, and 2h over h is 2. So C part is 2x plus h plus 2. Example 3 says determine whether the following equations define a function. If you'll keep in mind what a function is, when you plug in an x for an equation, you're going to get a single y. And if you can keep that in mind, then we should be able to just look at an equation and tell whether it's a function or not. Example 3a, let's do this. To determine if it's a function, get y by itself so we can see it a little bit better. Y minus 4x to the third minus 14 equals 0 would be y equals 4x to the third plus 14. Good job. Okay, again, function. Let's think about it. Function means each x implies 1y. If you have an x, then that x is going to be paired with only one y. Plug in any x that you want to into that. Plug in 2, plug in 3, plug in -4, plug in -5. Will you ever get 2 different values for y? Plug in anything you want to for x. Plug in 2, you're going to get a single y back no matter what you plug in for x. That is a function. A function. Okay, one more time. Hey guys, y'all please quit talking. That's getting all over my nerves. Thank you. A function means if you plug in an x, any x that you want to plug in, you're always going to get a single y. Plug in a 2, you get 4 times 2 to the third plus 14. You don't get 2 different answers. Plug in negatives, you don't get 2 different answers. Since each x that you plug in only gives you one y in return, that is going to be a function. B part is not going to be. Let me show you. Yes. That's the reason why. Y squared, let's move our x stuff over and our number over. Y squared is 3x to the 4th minus 8. To get y by itself, what do we got to do to both sides? Square root both sides. Anytime you square root both sides, you got to put a plus and minus in front of it. Remember that? See that? In this format, yes. If you had like a plus or minus something in front of it, that's not going to be a function. If you want to look at the graphs, here's another way to do it, guys. If you want to take and actually graph this, 4x to the third minus 14, it looks like this. I don't think we do the vertical line test this year. Might be tomorrow, actually. I'm probably getting ahead of myself. Yeah, vertical line test is tomorrow. But if you want to do it on this one, it's fine. If you graph them, and you can draw a vertical line, and all vertical lines only hit a single point, remember that? That is a function. So if you graph y equals 4x to the third plus 14, it does look something like this. Vertical line test, it passes it. If you graph y equals plus or minus a square root, you're going to get, it's not going to be exactly, but you're going to get something of this nature. Where vertical line test, you hit two different points, that's not a function. Or you can tell just by looking at the equation it's not a function. If you plug in anything, plug a 2 in for x. 2 to the fourth times 3 minus 8, no problem there, but when you take the square root of it, it's the plus and minus square root. Do you see there's two different answers there? It's the positive square root and the negative square root. So no matter what you plugged in for x, you have two different y values. The positive y value and the negative y value. No, this is not a function. Okay, next up on your notes, we're talking about domain convention. It says, unless otherwise stated, the domain of a function consists of all real numbers. Let me explain again what domain is. Domain is your x's. What are your x's? What x's can be? Okay. There's two things you need to remember for this section. Sometimes certain values must be excluded from the domain if, and these are pretty important to you. There is division by 0. You cannot have division by 0. That makes it undefined. The only other one that we're going to talk about in this one is there is a square root of a negative value. You can't take the square root of a negative. You can't divide by 0. Right? Can't tug on Superman's cape. Can't spit into the wind. Right? Any questions? So here we go. Don't mess with, yeah, something like that. Here we go. First problem. Domain convention. All it wants you to do is tell what is the domain. Unless otherwise stated, x can be anything. But in this problem, x can't be everything. There's one value, and when I ask you to find domain, I'll let you do it one of two different ways. Either you can tell me what x can be or what x can't be. If you tell me what x can't be, I'm going to say, okay, well then obviously x can be anything but those values. X can be any real numbers but this, this, and this. If you tell me what x can be, that's fine too. But domain in this case, x cannot be 3. Can it be 4, 5, 6, 7, 8? Sure, it can be anything but 3. Makes sense. That's what I'm saying. You can say what x can be or what x can't be. In this case, x can be anything but 3. Okay, there's only two things that can't have a 0 on the bottom, which is this case. What makes that bottom 0? You see, that makes sense. Or you can't have the square root of a we don't have square roots here, so we don't have to worry about the second case. So x can be anything but 3. Let's go back and let's review the lesson from Friday with this. If x can't be 3, could you write for me in interval notation all the things that x could be? Could it be 3.1? Could it be 3.01? You're going to have to do it different.
Everything but 3.
Can it be -2 and all those things below it also? X can be anything from negative infinity up to where?
So can it be greater
3 with a parentheses. Good job. Not including 3. Makes sense. And everything from 3 to positive infinity. That's fine. Either way, that's what I'm saying. You can write what x can be or what x can be. No, you never put brackets around infinity. It cannot include infinity because it's a concept, not a number. Here we go. Next problem. Scroll down. X squared plus 5x. F of x equals x squared plus 5x. Okay. You can't divide by 0. Can't take the square root of a negative. Do you have any of that here? What's your domain? All real numbers. What's another way you can write that with interval notation? Negative infinity to positive infinity. All real numbers. Any number can be plugged in for x. Good deal. The last one's pretty tough. Yeah, we're asked to find the domain of the square root of x squared plus 5x plus 6 over 2x squared plus 5x minus 12. A little bit tougher because now you got both of them. You got a square root and you've got a fraction. These are the two things. The stuff under square roots, x squared plus 5x plus 6 in this case. The stuff under a square root has to be, let's think about that for a second, cannot be negative. Can it be 0? We're just doing the square root now. Can that be 0? Can the stuff under a square root be 0? Can you take the square root of 0 is 0? Yeah, sure, no problem there. Can it be a positive? Yeah, you can find square roots of positives. So how do you write that? The stuff under a square root has to be greater than or equal to 0. Anytime you're dealing with square roots, those are the things that x can be. Makes sense. And what if I wanted to do the stuff that x can't be? I'd do x squared plus 5x plus 6 is less than 0, and that would tell me the stuff that x can be. Let's solve that. See if you remember. Factor xx plus 3 plus 2 is greater than or equal to 0. Negative 3 and negative 2, what do you do with those values? Not those values, but we're going to test, we're going to take a number line, negative 3, negative 2. Y'all remember that? Anytime you're dealing with inequalities, draw a number line, place this on a number line, and let's find out which intervals work, which intervals don't work. If you're dealing with quadratics, you can use the shortcut. Either the middle is going to work and the outside won't, or the outside will and the middle won't. So the best number to test is 0. Plug 0 into that. Does 0 give you a true statement? 6 is greater than or equal to 0. Is that true? Yes. So the intervals that's going to work will be this one and this one. And that is the things that x can be. So let's write that in interval notation. Including 3, or negative 3. And positive 3. Good job. That's the things that x can be. But we've got one other problem. What is it? The bottom cannot be 0, so we're going to have to take out probably 2 more of these values down here. So we're going to say, okay, 2x squared plus 5x minus 12 equals 0. I want to find out what makes that 0 because x cannot be those things. Makes sense. What adds to give me? I'll slow down. What adds to give me 5 multiplies to give me, what is that? 8 and negative 3, right? What do you use 8 and negative 3 to do? 2x squared plus 8x minus 3x minus 12 equals 0. I'll slow down and let you catch up with me. Okay, after you get a split, divide it into 2 groups. First group, second group. Out of the first group you pull a, and you're left with x plus 4. Out of the second group, pull a, negative 3, you're left with, which further factors into x plus 4 and, go ahead, 2x minus 3. I'm sorry. I do it back. I do it a different way each time. So x is, and x is 3/2. I'll slow down, let you catch up again. Okay, let's talk about the 2 values that we just got. Those 2 values are what makes the bottom of this fraction equal to 0. If you plug those into the bottoms, you would get zeros. So that's things that x, and if you want to put cannot equal, just to keep you straight, those are the things that x cannot equal. Well, a while ago we said that from just considering the square root stuff, this is what x can be. But out of that, we've got to take these values, and you can write it. You could write it like this. You could do something like from negative infinity to negative 3, and from negative 2 to positive infinity, not including negative 4 and 3/2. If you just want to do something like that, just to show me, because x can be any of this except for these two things. I like the way Sanders said it best. If we're going to take out negative 4 and 3/2 out of this, think about what that is on a number line. Here's negative 3, and here's negative 2. X can be all the stuff up to negative 3 and all the stuff from negative 2 and so on. But you've got to take out negative 4, and you've got to take out 3/2. So you're going to have 4 different ones. You've got to go from negative infinity up to that point, and from that point to negative 3. Then you've got to go from negative 2 up to that point, and then from that point up to positive infinity. And that's what Sandra was saying. Here's all the things that x can be. It can be anything from negative infinity to negative 4, not including negative 4. From negative 4 up to negative 3, including negative 3. From negative 2 to 3/2, not including 3/2. And from 3/2 to positive infinity. And that's it. Look at what I just put, though. The only difference between this and what I just wrote is this right here. I took out negative 4 and 3/2. It didn't include negative 4, and it didn't include negative. Yes. Yes. Here we go. Piecewise functions. What you got with the piecewise function is you've got pretty much a different function, all depending on what value of x you're plugging in. Let me explain to you what this right here says. F of x. You're going to plug into x squared plus 2 if you meet these conditions. If you got any x value between negative 3 and 2, including negative 3, which let's write that using interval notation. Might make things a little bit easier. From negative 3 to 2, including negative 3, not including 2. Okay? So if you plug in anything on that interval, you're going to plug it into x squared plus 2. From x is greater than or equal to 2, how do you write that? Bracket 2 to infinity. Good. So if you're on that interval, you plug it into 3x. But what if you're not on either one of those intervals? It's not defined. These are only the intervals that you can plug in to this piecewise function. So if it asks us what f of 1 is, what are you plugging in for x? 1. Does everybody understand that? If it asks f of 1, we're plugging 1 in for x, and we've got to know, okay, which one do we plug it into? The first function, you're plugging in all things from negative 3 to 2. The second function, you're plugging in anything from 2 to infinity. Which one are you plugging it into? 1? Yeah, that's on this interval here. It's between negative 3 and 2. So plug it into the first one. 1 squared plus 2 is 3. Yes. Yes. The last one is, it says the domain of f. It's going to ask you what the domain is. The second one, f of 2. Got to be a little bit careful on this one. Which one will you plug it into? The second one, because you start at 2 and you go to infinity. The first one stops at 2 and it doesn't include it. So we're going to plug it into the second one. So f of 2 is going to be 6. F of 4, you plug it into which one? Second one, because it's on that interval, which would be 12. Okay, finally, well, we got two more. It says f of negative 5. Which interval is negative 5 on? Neither one, so it is undefined. F of negative 5 is not defined on that. in this function. So since this kind of leads us to the next problem. Since negative 5 is not defined, we cannot plug negative 5 in. It's not in the domain. Okay, the domain is the stuff that we can plug in. When it asks for domain, what can we plug in? Negative 3 to whatever. We can plug in from negative 3 to positive infinity. That's all the stuff that x can be. We can plug in from negative 3 to 2 in the first one, from 2 to infinity in the second one, so the domain is anything from negative 3 to positive infinity. Or you could say x cannot be what? Negative infinity to, good job, negative infinity to negative 3, not including negative 3. Perfect. Okay, next up we're going to talk about the greatest integer function. Like I said, probably the hardest thing we've done today. Another name, if you can remember the name for it, another name for the greatest integer function is the floor function, or the rounding down function. All that this function does, when you see it's brackets. It's kind of like absolute value, but it's brackets instead of your absolute value bars. Another way that you might see it is like this, which I like that better actually. It's where you've got an L and backwards L. Instead of having the top parts here, they can chop it off. All the floor function does is it takes whatever you plug into it and it rounds it down to the nearest whole number. Rounds it down. This is the greatest integer function is the rounding down or the floor function. No. You have a ceiling function which rounds up. Okay, so let's plug in some stuff. F of 1.6 is simply the floor function of 1.6, which is 1. You just round down to the nearest whole number. The f of negative 12 fifths, this one's a little bit tougher. The floor function of negative 12 fifths, what I would do there is change it to a decimal. That's equal to the floor function of negative 2 point, let's see, that's 2 and 2 fifths, 2.4. Careful on this, round down to be negative 3. F of pi is the floor function of pi, which is 3. And the last one, the floor function of negative 3.2 would be negative 4.